Redox titration calculation. So first let's look at the difference between acid-base titration and redox titration. In acid-base titration, a neutralization reaction takes place between acid and base. While in redox titration, redox reaction takes place between oxidizing agent and reducing agent. And the second difference is in acid-base titration, protons are transferred from acid to base, while in redox titration, electrons are transferred from reducing agent to oxidizing agent. So let's look at the calculation. So question 1, all the iron in 2.00 gram tablet was dissolved in acetic solution. So let's underline. So 2.00 gram of tablet was dissolved in acetic solution and converted to Fe2+. This was then titrated with KMnO₄. The titration required 27.50 centimeter cube or 0.100 mole per dm cube of KMnO₄. Calculate the mass of iron in the tablet and its percentage by mass. Describe what would be observed during the reaction and how the equivalence point can be detected. So let's write down the balanced chemical equation before answering this question. So we have MnO₄ minus, that will get reduced to MnO₂+. MnO₄ is purple color. When I get reduced Mn2+, that will be colorless. So let's balance the equation. We have 4 manganese is balanced, but we have 4 oxygen on the reactant side. We have no oxygen on the product side, so we can balance it by adding 4 water molecule. Next step, let's balance the hydrogen by adding protons. We have 8 hydrogen on the product side, so we can add 8H+ on the reactant side. Next, we need to balance the charge because this is a reduction half, so we need to add electron on the reactant side. The charge on the product side is 2+, and we can make left hand side 2+ by adding 5 electron. So the reduction half is balanced. So this is reduction half. And okay, let's deal with the oxidation half. So where iron 2+ oxidized to iron 3+. Everything is balanced except charge. So for oxidation half, electron has to be on the product side. So the charge on reactant side is 2+. We need to add 1 electron on the product side. As we can see in our reduction half, there are 5 electrons involved. So we need to multiply this second equation with 5. So we will have 5 Fe2 plus have 5 Fe3 plus 5 E minus. Now we can add both equations. So electron will cancel with electrons, and we will have MnO₄ minus plus we will have 8H plus 5 Fe2 plus. On the product side we will have 5 Fe3 plus we will have Mn2 plus we will have 4H2O. So this is the balanced chemical equation for this reaction that will help us to do further calculations. So the first thing we need to do is we need to find out the moles of KMnO₄. As we can see, we have been given the volume and the concentration. So moles of MnO₄ and MnO₄ minus will be equal to, mole is equal to concentration times by volume. So concentration is 0.100, volume is 27.50 divided by 1000. Volume has to be in decimeter cube. If I solve this, that will give me 0.00275 moles of MnO₄ minus. Next we need to find out the moles of iron. So the moles of ions, if we look in the balanced chemical equation, so ratio is 1:5. So we can multiply the moles of MnO₄ with 5. So the ratio between MnO₄ minus to Fe2 plus is 1:5. So the moles of iron will be N of Fe2 plus will be 0.00275 times by 5. If I solve this, that will give me 0.01375 mole. Next we need to find out the mass, because we need to find out the percentage mass. So calculate the total mass of iron in tablet and its percentage by mass. So to find out the mass, so mass will be equal to moles times molar mass. So the moles of ions we have, which is 0.01375, and molar mass of iron, if you look in the periodic table, is 55.85. 55.85. If I solve this, that will give me 0.7679 gram of iron. So this is the pure iron present in 2.00 gram of tablet. So let's find out the percentage of iron in tablet. So that will be equal to, so the mass we worked out, so 0.7, round this to 0.768 divided by 2.000 times by 100. So that will give me 38.39%. Let's go back and see what else they have asked us. So we have find out the mass, which is equal to 0.768 gram, and the percentage is 38.39. But the last part of the question says describe what would be observed during the reaction and how the equivalence point can be detected. So this is the reaction where KMnO₄ acts as a self-indicator. So KMnO₄ self-indicator. So right at the start, we will have a purple color in the burette. So in the burette will be purple color, but the equivalence point, we will observe a colorless solution in the flask, but one extra drop of KMnO₄ will bring the color to purple color. So we can write down MnO₄ minus in the burette is purple, but forms nearly colorless solution. So when MnO₄ reduced to Mn2 plus, but when all the Fe2 plus has been used up,